cats and dogs, fish are the most popular household pets. In the US alone, there are currently 148 million fresh and saltwater fish swimming in tanks somewhere, waiting for their next feed. Like any pet, fish require a bit of maintenance. You need to clean their tanks regularly and find someone to look after them when you go on holidays. But things are different at the London Aquarium. Although there are only 3 in the world, it's not in danger of extinction. It doesn't eat anything, but we can't eat it. And if its inventor has his way, that's right, inventor, one day every home aquarium will have its very own man-made, fully rechargeable, artificially intelligent RoboFish. Isn't that amazing? If you squint your eyes, you would imagine that's a real fish. It's swimming through the water just like a real fish. It pauses every now and then and just glides, as a fish would. And when it gets to the end of the tank, turns around looking really fish-like and comes the other way. Now, there's no one controlling that, no remote control. It's doing it all by itself, thanks to some really clever but remarkably simple robotics. Clever because water is a difficult environment for a robot. It has to deal with abnormal pressure. It has to move differently to a land-based unit. And of course, it has to be completely sealed to prevent leakage. The simplicity lies in the artificial backbone. That extraordinary lifelike swimming motion is made possible by just 3 movable joints. Not bad when you think of how many bones your average fish uses to achieve it.
Wow!
Look what you've caught! Professor He-Shang Hu from the University of Essex has spent 3 years developing RoboFish. What gave you the idea of a robotic fish?
I think the basic idea, we try to bring the robots more close to people.
Right.
Because we see 21st century is the robotic century.
Yeah.
Big invention will be robots.
Yeah, what amazes me, I mean, it's quite simple. The robotics is quite simple, just got 3 moving joints.
Yes.
And yet it looks amazingly real.
We actually took the picture of the real fish movements.
Right.
We're doing the analysis. We built the model inside of the computer.
Lifelike movement is one thing. Controlling it is just as complex. Of course, the big thing we want to know is how this fish self-navigates through the water. Well, it is bristling with sensors. So in here is a tiny gyroscope. In fact, we've got one here, that little chip there. That allows the fish to maintain its orientation and do that fish swimming motion through the water. There is a pressure sensor in here, one of those. And that measures the pressure in the water, and from that the fish can work out its depth, because of course the deeper you go, the higher the pressure. So the fish can work out whether to go down further or come up to the surface. Just like a real fish, it even has its own swim bladder, a small pump which allows it to rise, fall or stay still by varying the amount of water it takes in. Navigation is via 4 infrared sensors under RoboFish's jaw, with a range of about 30 to 40 centimetres. That's a little over 12 inches. Now the brains that control the whole thing in here, 4 computer chips, one of which is the chip out of a PC. So some pretty powerful computer grunt here. Impressive little fish. The next challenge, solve the problem of RoboFish's life expectancy. Currently about 5 hours before it needs a recharge. Professor Hu hopes the next generation will be smart enough to detect low voltage and simply swim into an underwater charging station. So why would you want to make a RoboFish? Well, there's novelty value, of course, but there's also a serious side to this research. The scientists want to discover a new way of propelling man-made vehicles, like robotic subs, through the water. Today, of course, we use propellers, but they're not that efficient. These guys have been evolving for millions of years, and they've just been fine-tuning their swimming. Turns out that fish way of moving through the water is highly efficient. So the scientists want to discover the principles behind it, mimic them, and apply them to human-made craft.
Okay.
Throw them back in, that's right.
Let's go.